the Whirlpool model. Here if you see that one binary system, that means FeS, so pure iron and sulfur. So sulfur also can act as a surface active elements. See here we can see that it is a combined effect of 3-dimensional figure, that once the surface tension force is the function of here the temperature as well as the activity of sulfur. That means amount of the sulfur and temperature both actually makes a combined effect on the surface tension force, and here you can see. So this figure shows that nature of the surface tension force. We can see that with respect, if you look into the with respect to the temperature. So at certain temperature, optimum temperature, there is a surface tension force is maximum for a fixed amount of the surface active element, and other cases if you see that combined effect very small amount, the surface tension force becomes very maximum, it is a very small amount of the surface active element and probably at the high temperature. So this 3-dimensional figure will be better explained in this way, that in this case that here the surface active elements is low in this case. So very small amount of the surface active elements, or I can say that there is no surface active elements. So in this case that we try to represent the Marangoni convection, nature of the Marangoni convection in the Whirlpool like that. So it is the in case of the pure iron, that means there is no surface active elements, in this case a z the depth direction, and on the top surface the what should be the Whirlpool width in this case. So here the shear stress is basically acting from center to outward periphery. So that actually try to drive the molten material from center to outward periphery, and we can say it's try to create on this plane some material flow occurs in clockwise direction. So with this nature of the material flow, actually try to increase the width of the molten pool and try to decrease the penetration of the molten pool. So that means in case of pure iron, that means without any effect of the surface active elements, normally we can expect the wider width and the low depth of penetration, depending upon the, it depends on the nature of the material flow or nature of the Marangoni convection that happens within the Whirlpool. But in other cases, if we look into this other part, in this case metal is having considerable amount of the surface active elements. So it's a, I can say it's a binary system, FeS system, and is focused on that metal is having the considerable amount of the surface active elements and certain temperature, it achieves at the certain temperature. So in this case what happens, that shear stress we can find out that shear stress in this case the viscosity into velocity gradient something like that. So that shear stress acting on the surface is not exactly outward direction, it is acting the inward direction, and that shear stress is basically comes from the effect of the nature of the surface tension force, and then surface tension force, and that shear stress is linked with the velocity gradient. So that means that metal is flowing from outward periphery to the center direction. That means it will try to create the flow of the metal flow, it is like that some anti-clockwise direction, it is completely reversed from the pure iron system, pure Fe system. So when it is making the clockwise material flow, that impact on the final Whirlpool shape like that, it actually decreases the weld width, but it try to increase the depth of penetration. So that way, that in this way basically that once it is surface tension force changes, gradient changes with respect to temperature and the concentration of the surface active elements, and that finally it influences the Marangoni convection of the Whirlpool, and it basically impact on the shape of the Whirlpool. We can further try to look into that, try to present this thing, that surface tension force temperature and these two cases, one is the, in case of iron, it is represented by the simply negative slope, that means slope is less than 0, and this temperature coefficients of the surface tension we can say, and other cases the APS system. So, in this it is a binary system, that means the APS system, it basically takes the include the effect of the surface active element. So, in this case with reactive to temperature, it reaches the optimum value, the positive slope up to certain point, then the slope becomes 0, and then again the further increment of the temperature, the slope actually changes to the negative. So, up to that point it behaves the completely different from the pure iron system, but when you cross the optimum point, then the slope its slope becomes negative. That means slope becomes negative means it is the similar phenomena, similar situation like the pure iron. So, that means there is no effect of the surface active elements beyond certain optimum temperature. So, that is better explained in this way, that shear stress can be defined by the shear stress is acting on the fluid surface of the fluid in terms of the first derivative of the surface tension force, because surface tension force is basically represented by the force per unit length. So, then when it is derivative with respect to length, then it becomes the stress value. So, then shear stress is linked the surface tension force, and then this surface tension force derivative of the surface tension force can be written in these two components. One is the temperature differentiation of the surface tension force, and second part is the temperature gradient. So, with this decomposition of these two components, it helps to explain the effect of the surface tension force. So, that temperature gradient of the surface tension force, it can be negative or positive depending upon the nature of the presence of the surface active elements or presence of the surface active elements. It can be, for example, in case of pure system it becomes negative. If it is having the surface active elements, that slope becomes positive. And the second component is the temperature gradient. It is always negative, because at the center point of the oil pool the temperature is the maximum, and the outward periphery and the boundary the temperature becomes less. So, that means temperature gradient is always negative in this case. But the nature of the stress, so combining these two, we can say that the shear stress acting on the layer of the fluid liquid metal, they can be positive or negative. That means their direction can change depending upon this value of the temperature coefficient of the surface tension, whether it is positive or negative. Depending upon this value, the sign of the, or maybe magnitude, and the, we can say the magnitude and the direction of the shear stress, it may change from positive to negative. So, here the shear stress in this direction when there is a temperature coefficient of the surface tension is negative, and it is in the opposite direction when the coefficient of surface tension is the positive. That means it is corresponds to the APS system, that means presence of the any surface active element. So, in that way change of the sign of this shear stress is basically acting on the top surface of the liquid molten metal when it is interacting with the, of course, with the shielding gas. Then there may be they can change the direction of the material flow, and accordingly the size and the shape of the metal oil pool can also be changed. So, with this phenomena or this basic physical or basic observation from the effect of the surface active elements, there are some allied process, welding process are also developed by considering the effect of the surface active elements. So, that means if it is possible to add some amount of the surface active elements within the oil pool during the welding process, that can consider the positive effect of the surface active elements. That means it can affect on the oil pool shape. So, but what are the different way to consider practically the surface active elements becomes the final part of the oil pool. So, there are three different way. First is that minor elements, that means either oxygen or sulfur. In general, we consider these two components, the minor elements can be added by adjusting. First is the chemical composition of the base metal. This is the one way, chemical composition of the base metal. That means the surface active elements already becomes the part of the base metal, and when you try to weld that base metal, then there may be the effect of the surface active elements. Or there are other way also, simply spreading the fluxes, that means halides or oxides on the substrate material. So, simply making the different oxides, the coating of the oxides on the material which is supposed to weld. So, in that way also it is possible to supply the surface active elements, and there is the another way, directly using these surface active elements with the shielding gas. That is another option. For example, sometimes the carbon dioxide gas CO2 can be used with the argon shielding gas, and that here the oxygen can impact or act as a surface active elements to alter the shape and size of the weld pool. But overall, addition of the small amount of the minor elements to the base material significantly changes the weld penetration. So, based on this three different way we can add the surface active elements. There is one development of the process that is called industrially activated TIG welding process has been developed. Activated TIG welding process means activated tungsten inert gas welding process. So, in this the activated TIG welding process can be defined in the following way, that ATIG is the simply variant of the TIG welding process, or we can say the gas tungsten arc welding process. So, what happens in this process, that sometimes we use the application of the thin coating 10 to 15 micrometer thin coating of the activated flux is added on the specifically on the joint area before welding. So, once it can be done before welding, and then we can do the normal TIG welding process, tungsten inert gas welding process, or it is called also GTAW, gas tungsten arc welding process. So, once we do the normal welding process, then this surface active elements actually affect on the, and it finally changes the weld pool shape and size, impact on the final weld joint properties basically. So, in this way we can, the ATIG process is basically, this is the way we can overcome the conventional TIG welding process by simply developing this process. So, of course, the ATIG is the activated TIG welding process, simply buying the coating amounts, but some researchers also develop that directly adding the surface active elements, for example, carbon dioxide with the argon shielding gas, and that can also be used as a modified TIG welding process to include the effect of the surface active elements. But activated TIG, different activated TIG welding process is here normally we use the coating of the coating of the activated flux. So, that is the difference here. So, what are the typical advantages of this process? That the basic advantage of this process is that it enables the single pass welding of the higher thickness plates. So, single pass welding of the higher thickness plates, and not necessary to do the multiple welding, because it considerably increase the depth of penetration. So, multiple passes is not required in this case. That is the one significant advantage of this process, and of course, enhance the productivity and reduce the consumption of the filler material. In this case, a residual stress can be reduced significantly, more than 70%, and the weld joint are basically almost distortion free. Distortion can be avoided using this activated TIG welding process, and of course, the significant reduction in the cost of fabrication, more than 50% in general, because as compared to the say normally TIG welding process is low cost process as compared to the laser welding processes. So, of course, laser welding we can achieve the high depth of penetration because of the high concentrated heat, but even TIG welding also we can achieve the high depth of penetration, only we need to modify this by including the effect of the surface active elements. But practically when we try to use the incorporate the effect of the surface active elements, we need to do a prior investigation is required to find out the optimum quantity of the surface active elements of a specific welding system. That is important to know, because at any quantity or is may not possible to achieve the effect of the surface active elements positively.